All right, so we saw above that we can get at the command line arguments that are passed in on a program through the sys.argv list, but it's going to be potentially difficult to deal with, many command line arguments and optional arguments and positional arguments, and so there's thankfully numerous tools for doing command line argument parsing. And some of these of the popular ones, one is called argparse, and this is part of the Python standard library. So nothing else to install. You can build them through argparse. There's another popular one called click. That's also for building command line interfaces, and it uses something called function decorators. That's what this add click. These are. Anytime you see the at, that's usually it's a decorator. But we're going to use argparse. It's part of the standard library. It allows you to do parsing for command line options. And it's good to use something that we don't have to install anything else. And if you're going to be doing these, you need to learn about argparse first. It's kind of the base upon which everything else is compared to. So there's a couple tutorials. There's this gentle argparse tutorial. That's this guy seems to be pretty popular. It's if you want to take a look through. And though again, the people from Real Python have done a very nice argparse tutorial, really comprehensive. Even if you just go through kind of the beginnings of it to get a sense of it, it'll augment kind of what we do here. So there's kind of four main steps to creating a CLI with argparse. Of course, you have to import the library, and then you create a parser object. And then what we do is we add arguments to the parser object, and we can add arguments of different types. They can be required arguments, they could be optional arguments. We can include things like default values and help phrases, and so we can even do things like having certain actions happen if a flag is there. And then once we do that, we use it by calling the argparse method of whatever we called our parser object. And what you get back is something known as a namespace object. And the attributes of this thing are just the which we get at through dot, as we'll see in a minute, are just the input arguments that we specified. So what I did is I rewrote that echo underscore args.py example using argparse, and I called it, not surprisingly, echo underscore args underscore argparse.py. And it does the same thing. It just prints out args, which is the namespace object, and var sub args, which is a dictionary version of the same thing. Vars is a nice built-in Python thing. If you pass it a namespace, it will give it to you back in a dictionary form. And you can get at any individual item in a namespace through dot. Like if we've got one that's called IAT, which we will, you can do args.iat. So I'm going to run it, and then we'll go look at it. So I'm running this echo args underscore argparse, and I'm passing in our same 5 optional command line arguments. Okay. So I run it, and so notice it comes back. What it returns, it's showing us what args is. It's a namespace object, and you can see it's just the individual arguments and their values. There's a dictionary version of the same thing, and we can get at a specific element or attribute of args with dot. So I'm going to open up echo args underscore argparse.py with Notepad++. And so notice, first of all, I'm importing the sys module. No, I'm not sure I'm using it. Might have been left over, but I'm definitely going to use argparse. So I've got a function here. And if I collapse that, notice down here I've got a main function that's actually going to call this process command line. All right, so this process command line is where we're going to create our command line interface through argparse. So the first thing we do is we create an argparse object or a parser object, and we're doing that with this argument parser constructor or function. And I'm just going to call it parser. That's fine. And I can give it some arguments. One thing I can do is I can give it the name of the program, and we're going to use this eventually, this idea for our vaccine clinic model 4. So I'm gonna put that there. So instead of it, the first instead of it using the name of this program, the Echo ARGs, this will be the name of the program. And then here's a description. This will show up in the help. You'll see run vaccine clinic simulation model. So I've got an empty parser object. Now I'm going to add arguments to it. And I keep using the parser object and then the add arguments method. And you can do required arguments, positional arguments, anything started with the flags, the hyphens, the single hyphen or a double hyphen. Are optional arguments, and notice you can put a little help message with each one of them, and then you can specify the data type. Again, this will come in handy because you'll see this is going to automatically generate help. You can actually do things like have both short versions and long versions. So I could do whoops. I forgot the hyphen on that first one. All right. So you can actually, have command line arguments. Whoops, that's an equal sign. So our real simulation model is going to have a whole lot more than this, but this is just to get us started. So create a parser object, add a bunch of arguments, and then do the parsing. And that's when we take our parser object, parser, and we use the parseArgs function, and it's going to return a namespace object, and that'll get stored, and I'm going to call it args, and then I'm just going to return that namespace object. So when we run this thing, right, if we run it from the command line, then what will happen is that this main will get called here, and that will then cause this to happen. Process command line will get called, and then I'll go ahead and I'll print out things just like I did in the other version. Okay, so this guy is echo args underscore argparse. So let's go back to our notebook, and I've already got the command line all built, and so you see how this translated to printing those things out. Let's just try and see, make sure we got that right. Let's see if should be able to use the short version as well, and we can. All right. In fact, notice it says it still recognizes that argument is the IAT argument. So what our goal is going to be is we're going to add this kind of process command line function to our clinic model, so that we don't have to store all these inputs inside the program itself. So at this point, we need to leave the notebook world. Our next version of our clinic model, the clinic, which I'm calling vaccine clinic model 4, is going to be a whole lot more complicated. And so what you should do, you can find the model, right? There's 4. In fact, there's a couple subsequent models. Oops, not that. I'm sorry. Vaccine clinic model 4 right there. And then there's going to be, you'll see there's extended versions, and I'll talk about. So what we want to do is we want to open up this in PyCharm. And so what we're going to do is we're going to create a PyCharm project that's based on this folder here, the vaccine clinic folder. I've already done that. All right. And you can tell that I created it, that I created it based on, all right, so you can see here's my top level project folder, the one that's in the DES directory. And then I can see inside I've got my source folder, and then there's my vaccine clinic folder, and there's the various Python scripts. Okay, so if you I've gone through a couple times before how to create a project in PyCharm. and you can just, do a file new project, and you can actually then tell it to base it on an existing folder, which you'll do here. You can also just open up the files in a text editor if you want to look at them that way, or you can open it up in Visual Studio Code. I don't care. Um, but what I'd like you to do is get the Vaccine Clinic Model 4 open, and I've got it open here. And one nice thing about PyCharm is it's got the ability to do code folding, which actually a lot of text editors do, like Notepad++. I can fold code by clicking this little minus sign, right? I can fold all my code. Then if I just want to look at one piece, I can expand it back out, which is really quite handy. I've done the same thing here in Vaccine Clinic Model 4. So I've got everything collapsed just so you can see we've got, this is very similar to what we did in the last notebook. When we created our vaccine clinic object, we had a get vaccinated function, a run clinic function. The compute durations was we just did that as a post-processing thing, but now I've moved that into a function. We had a simulate function. We did not have a process sim output, and we'll talk about that in this version. We did not have a summarized patient log. We did that all manually in the notebook. But here's our process command line. So we just want to take a look at that. So I'm going to expand it out. Oops. All right. And so just like I did in the simple example, I created a parser object, and then I started adding a whole bunch of arguments. So I noticed this very first one, this minus config. Eventually, so let's just hold off on that. We'll go back and talk about that. But if you start looking at the other ones, you can see there are things that we're used to seeing: the patient arrival rate, the number of greeters, and the different kind of staff levels, the percent that need a second dose. And then I've actually got all the means, and if they need a standard deviations of all the different processing times. And so notice I've actually set the defaults to kind of what we were using before, just to make it easy for, as I'm kind of testing things, that these things that already have reasonable default values. Each of them has a nice little help message, and then there's a data type that goes with it. So it goes all the way through the observation time, and then even the amount of time they stay after the 15 minutes. I've included that as a variable. And then also I've added a scenario argument, so we can give it kind of a string kind of label, and these get appended to the output file names. And then, in fact, and for the default of that, it literally just uses the current date and time. The stop time, how long we want the simulation to run, how many replications do we want to do. And notice I set the default to 1 and 10 hours, 600 minutes. And we can even pass in the random number seed. And also we can pass in an output path to tell it where to write the output files to. And the default is nothing, which is then ends up defaulting to the current directory. And then I've also added a Boolean argument, this minus quiet, but it does, all the rest of these have values, but for this one, it actually, what it's saying is if this thing is there, if minus quiet is on the command line, then I want you to store the value true. And if we set quiet to true, it just means the program is not going to print out all those output messages. But if we don't include the minus quiet, then the program will not be quiet, and it'll show all these. All right, so we've got, I don't know, whatever, 12, 15 command line arguments. We'll go ahead and process it. And then, and then let's just skip this next line too about this config, and then it just would return it, and our program would go on its merry way of somebody else could use this args namespace then to set the values and use them in the simulation model, which we'll get to how we change that. The last thing I want to kind of show you is as well about this config option. Obviously, this is a lot of command line arguments, and we really don't, it's not going to be very fun to type out command lines, a gazillion times. Kind of hard to read with this many options. So another thing that's common when you're doing things like simulation experiments, is to use something known as a config file. So just a simple configuration file that contains all the input parameter arguments and values. And so what we're going to also do is have the ability to put minus minus config and then pass in a file name of a configuration file. So and then what will happen is when we parse this thing, it'll look and say, hey, if that config guy is not none, so if the user passed in the name of a config file, then it says, hey, read the inputs from the config file. And all this does is literally open up the config file. What's kind of cool is you can literally run the parse args guy just like we did up here. But you can actually base it on the inputs of the file. So notice this thing, right? That when we open a file and we say as this is a variable kind of representing the file. It's like we call it a file handle. And so what this is doing is saying, hey, take the file, read all the lines, and split it. And this will split things on white space. And you'll see if I take a look at let's look at what one of these configuration files looks like. Oops, vaccine clinic. So I store mine in this input folder, and so I'll open up this base underscore v12 config, and I gave it a CFG extension. Okay, so what's happening is these things get read in all the lines, and then they get split on the spaces, and so you can see that what you end up with is each argument and its value. So by creating these config files like this, I don't have to type all the stuff on the command line. We can literally just call our program by the name of the Python program and then minus minus config and then give it the name of the config file, which we will do. Okay. And also I just want to kind of show you what is really nice is in fact here we will do this in the terminal. So if I do Python vaccine clinic model 4.py, perfect, and I say minus minus help, or I can also just do minus h. All right, it literally will print out this nice kind of help thing for us. And it'll say, hey, this is how you use this thing. You give it the name of the program, and then here's all the different flags you can use. And then it gives you, so this is, you can see where our all of our little help messages kind of showed up here, and even the default values, which is kind of nice. And if I run it with a config file, and I'll do it here from the command line. Let's see, I can just do, if I do minus minus config, and I've got one in the input slash we call it base underscore v12.cfg. All right, so now we're saying, hey, run the clinic simulation model and get all of your inputs from this configuration file. And so literally there's our, and we haven't dug into the details of this version of the model yet, but and boom, we're all done. You notice now we'll see we've extended the model to print out all kinds of stats and things like that. So all right, let's go back to the vaccine clinic model 4. So make sure that you what we're going to do next is we're going to dig into this vaccine clinic model 4 program, so we can kind of look at the structure, talk about some of the changes that we've made it a whole lot more powerful than our notebook versions. And I also want to point out that and I encourage you to use PyCharm, and while in the next video when I'm kind of going through this, kind of use PyCharm with me to go through it. I also wrote little kind of driver programs called use and then the name of the model. Again, all this just to kind of make my life easier as I was kind of testing things and developing things. So for example, I'll show you what use clinic model 4 is. Okay, all it does is it instead of using a config file, which I could also do, which I'll show you that, I also allowed myself to be able to run it this way by just creating a dictionary of all the input arguments, and I just put a bunch of the values that I wanted in as I was testing, and then I'm calling various, like I'm calling the simulate function, and then I'm calling some of the output functions. So we'll play around with this as well. But at this point, what I'd like you to do is get Vaccine Clinic Model 4 open in PyCharm. You should have again, create a PyCharm project based on that. And I'm going to collapse this, and we will kind of talk through some of the improvements that we've made to this model.